Above-ground piping systems for fuel are standard steel pipe, either single wall or double wall, since soft metals or plastic pipe is not allowed by the code. The design for fuel system piping is pretty straightforward for sizing and head loss. We wanted to address some of the common problems with above-ground pipes.
Above-ground pipe is typically steel, Schedule 40 standard wall pipe, as required by most building codes. The finish is black, since galvanized pipe is thought to cause corrosion issues. Pipe connections are best welded, except at tank fitting and certain equipment that is available only with threaded connections. Flanges are preferred rather than unions for long-term tightness. Where secondary containment pipe is used, it is typically steel pipe, Schedule 40 with welded connections. There are some PVC secondary containment systems for use with steel pipe, and these must be considered carefully because of the difference in thermal expansion of the materials. Double containment of above-ground piping is often used where required by the local fire marshal or user facility standard. Welded steel pipe that can be visually inspected is an acceptable standard in many circumstances, particularly within a tank area or tank room, or a generator room with controlled drainage. In our view, double containment should be used for all piping routed inside buildings, except where it is within a rated area such as a tank room. Above-ground welded steel pipe that can be readily inspected and serviced is sometimes provided as single pipe route without redundancy. The potential for damage is not as great as with underground piping, where redundant piping should always be used. Leakage from threaded joints is probably the most common problem for fuel systems. For this reason, welded joints should be used to the greatest extent possible. Threaded joints, where required, should be located within containment areas. Thermal expansion is perhaps the second most common problem. When fuel from a relatively cool tank enters an above-ground pipeline, it is likely that thermal expansion will occur. Thermal expansion of the fuel causes the pressure to build in the piping, and this piping must be relieved back to the tank. So any pipe section that can be blocked in with valves need to have an expansion relief device routed back to the storage tank. Visual inspection at regular intervals is the most common form of leak detection for above-ground piping. Double wall piping is monitored with continuous electronic leak sensors, typically located at the low points of the piping run. Electronic pressure type leak detection systems are sometimes used. However, their track record is mixed primarily because of the difficulty of accommodating the temperature changes along the length of the pipe.